Hello, my name is Rafael Ramos, and I'm a member of Machine Learning and Data Science Laboratory at Federal University of Minas Gerais. And I'm going to present our work entitled as a C4.5 fuzz decision tree method for multivariate time series forecasting. Well, we'll start with an introduction covering the initial concepts of time series, fuzzy time series decision trees, and fuzzy decision trees. Afterwards, we will talk about the IBOVESPA index future contracts as well as its concepts. The FDT-FTS method will be explained as well as its results using the future contracts dataset. Also, in the end, we will present the conclusion and references. Well, talking a little bit about time series. Well, time series data is a set of points collected at regular intervals and chronologically ordered. Usually, sequential data presents statistical dependence and autocorrelation can be computed. Autocorrelation can happen among different time series. Some of the challenges of time series forecasting are, well, usually traditional methods have some premises that are not maintained in time and have low explainability. An important classification is about univariate and multivariate time series. The first one is a series with a single time-dependent variable. And the second one, well, is more than one time-dependent variable, which means that each variable depends not only on its past values, but also has some dependency on other variables. Some time series regression models and algorithms are ARMA, ARIMA, Hotwinters, among others. Talking a little bit about fuzzy time series, we have that the universe of discourse from the time series data is divided into many fuzzy groups. The linguistic variables are represented as fuzzy sets through time, and from the fuzzified data we can extract fuzzy rules to predict future values. Well, we have some related works on the FTS field, such as the PWFTS, the hybrid method using Safirma and FTS methods for non-stationary datasets, and hybrid method combining FTS and convolutional neural networks for short-term load forecasting. Well, decision trees are designed for classification and regression problems, and one of its main characteristics is the generation of a tree as data structure with independent paths. While some advantages are it can handle large data sets, one is a lightweight algorithm, since decision making can be done by rules. The rules are comprehensible. Also, we have a very low computational complexity, and there is no need for normalization, feature scaling, or feature selection. Some related works are the C5.0, C4.5 card, Scikit, and the Random Forest, which is an ensemble method. Well, the C4.5 algorithm is an extension of the ID3 algorithm based on entropy and information gain calculation. And it can be used for both discrete and continuous attributes, and the branches can be binary or n-ary, right? Well, the C4.5 is a classification method. We do not have a regression method based on the C4.5, and it uses the single pass pruning process, which is the pruning method that it is used in order to avoid overfitting. Well, and we have the fuzz decision trees, which are basically decision trees trained and tested with attributes previously fuzzified, or attributes in which fuzzification occurs during the decision tree induction. Some related work on fuzzy decision tree algorithms are the FDT, the FUZZ-IEEE, and the SDT. Well, in financial time series, the premises such as normality, stationarity, and well-defined levels and trends usually are not fulfilled in time, and that's because that type of time series are influenced by many external facts, which leads to a concept drift, which is the fact that statistical properties and the relations between input and output variables are changing over time depending on the context. Well, the present project intends to apply the FDT-FTS method in order to forecast the IBOVESPA future contract. Well, the IBOVESPA future contract is a syntactic derivative that represents a stock portfolio of 85% of the total trading volume at the IBOVESPA market, known as the B3 market. Well, it also can be used for hedging or statistical arbitrage in order to prevent market losses. And also, in order to predict the future contract time series, we're going to use technical indicators and as well as lags from its time series. Well, now you're going to talk about the FDT-FTS method and its steps. As an initial step, we have data analysis, in which a descriptive and inferential analysis is performed. In a second step, the fuzzification of the data is done. In this case, the output and the input variables are converted into fuzzy values. Then we have the decision tree training using those fuzzy values, in which rules can be extracted. In this case, the Mandani method for the differentiation will be applied. And the differentiation is done by calculating the centroid, and in this case, we have an FTS transformed into a numerical series. All these steps will be demonstrated on the next slides using the series of future contracts as a case study. Now we are going to talk about data analysis and data acquisition. First of all, data was acquired from the MetaTrader 5 platform linked to a Brazilian broker, which is connected to the B3 service, right? In this case, we collect 10,000 closed price values from the IBOVESPA future contract, represented by the wing foot symbol. Instead of forecasting the original time series, we're going to forecast the first difference time series because it's stationarity properties. And here's the formula. When you predict the first difference plus the closing price, and we make the summation of both, we have the closing price T plus 1. Then we have basically the next closing price, right? Well, here we're going to talk about the input variables. In this case, we are using 5 technical indicators from the original closing price, and also we're collecting the lag T-1 from the differentiated time series, right? Here's the collection of all the technical indicators that we are using, plus the first difference series delay of T-1, and here you have a graph of the difference between high and close values. Here we have a sort of data analysis. We can see that in these two figures, the linear autocorrelation is weak or non-existent. That is interesting because some kind of non-linear autocorrelation can be captured by the method. Well, here we have an example of how output and input variables are fuzzified. The first figure, we have the first difference and how occurs the process of fuzzification. And here we have the one example of input variable fuzzification. Well, here we have the training and testing. Basically, we are using the time-based cross-validation, which means we are using a sliding window for training and testing the FDT. And we use 100 different training and test windows over the 10,000 points. Here in the figure, we have an example. We have a slide time window for the training and a slide time window for the testing. Here we have an example of the FDT generated. We generate a FDT with max depth equal 2. And that's just an example of the route, the path, and the leaf of the decision tree generated based on the fuzzified attributes. Now we're going to talk about the differentiation process. And first of all, we have the rules extraction from the FDT. Here we have an example of rule 4, rule 2, rule 5, and so on. And we can apply the Mandani method for the differentiation of those rules. Basically, we have the fuzzy groups with the centroids. And if we apply the centroid calculations of the fuzzy groups, we are going to extract the value of the centroids. And in this case, basically, we're going to calculate the midpoint of each fuzzy group. Well, here we have an example of the differentiation process, which is showing a figure of a fuzzy time series, an FTS converted into a numeric time series using the differentiation method explained before. And basically, we are transforming the FTS into a numerical series. In this case, the FDT is predicting the fuzzy values, and with the differentiation, we are predicting the first difference time series. Well, now we are going to some results and discussions. We're going to compare our FDT-FTS method with the Support Vector Regressor, which is a powerful method for nonlinear regressions. Also, we're going to compare our method for the Random Forest Regressor, which is an ensemble method. The metrics that we are using is MAPE, SMAPE, RMSE, the normalized RMSE, and MAE. And we can see at the table that the results were pretty close because all the metrics results had a close intersection. Now here we can see that the FDT-FTS predictions could capture most of the movements of the original time series. The red line represents the closing price forecasted by the C4.5 fuzzy decision tree. And look at the original closing price time series on the blue line. Also, we can see that all algorithms suffer with the variance, which is a volatility measure. And we can see that all metrics, the RMSE, the normalized RMSE, the MAE, the MAPE, and the SMAPE, has some sort of correlation with the variance curve over the experiments. Well, in addition, it is possible to calculate the feature importance using information gain. And it represents a metric of explainability of the decision trees. And it's quite interesting to observe that in our case, that the most important feature is the fuzzy variable, which represents the like t-1. And some slides before, we showed that the like t-1 doesn't have any type of correlation, but kind of our FDT-FTS method could capture some nonlinear autocorrelation between the like t-1 and the present values. Also, the second best variable was the fuzzy RSI1, which is a technical indicator. And the third best variable was the difference between two exponential moving averages. Well, to finish the results and discussions, we are going to make a time comparison between the FDT-FTS method and the SVR and the Random Forest Regressor. In this case, the FDT-FTS method had a better training time, and the test was done on a computer with the following characteristics. A macOS with 8 GB with a processor Intel Core i5. That comparison is important if you want to run your algorithms on an online application. It is better to have lower training time. Well, in conclusion, the FDT-FTS based on the C4.5 tree presented competitive results considering the mean and variance of the metrics used. And the results were close to the other algorithms once the metrics distributions presented a huge intersection. And as future work, it is necessary to explore hyperparameter optimization related to the number of fuzzy partitions on input and output variables. And here is the references. And thank you for your attention.